Hello, dear young minds. Welcome back to Physics Point. We have reached at the sixth video of the chapter Gravitation, and in this video, we'll be talking about fluid pressure, and buoyant force. You must have heard a phenomena called buoyancy, right? What is the meaning of this buoyancy, and what is this fluid pressure, and what is the meaning of fluids? What are the examples for this? I will get you through details of all these things in this video. My name is Shrikant Bashetti. I welcome all of you to your beautiful physics channel, Physics Point. Let's get started. The first thing first, what is the meaning of fluid? Take out your pen and notebook and start to make the notes. Fluid means any matter which can flow is called fluid. Okay, which can flow freely, freely also you can write here. Any matter which can flow freely is called fluid. What are the examples for fluids? The liquids and gases. Alright, so any liquid for that matter, it can be water. Alright, it can be phenol, it can be liquid hydrocarbon, it can be alcohol. Alright, so all these are the example for fluids. How about gases? Gases can be O2, then you can have CO2, all these gases, any gas. Alright, so more about these gases will be studying in 11th standard, but our focus will be on liquids in 9th standard. So whatever properties of these fluids are there, no? Properties of fluids. Whatever properties of fluids related to its motion, related to its motion, related to its motion, all that will be studied in a branch called fluid mechanics. Fluid mechanics, and that fluid mechanics will be introduced for you in the 11th class. Right now our main focus will be on liquids. All right, fine, then let's move forward. So there is one word that is fluid pressure. What is the meaning of this fluid pressure? Let us have a look at that. For example, this is a container. We have got one container here. For example, let me show that container over here. So this is the end of the containers, right? So here is the container. We have got one container like this. All right. In that all these are the molecules. So here are the molecules. Look at these molecules. They are freely roaming around. All right. So what they do, these molecules are going and hitting these walls. Look at this. These are going and hitting the walls of the container. No, look at this. And this side also they are going and hitting the walls of this container. Look at this. And here at the bottom also they are going and hitting. Can you observe this? And here also at the top also they are going and hitting. Okay, so whatever these molecules are there, no, they are going and applying some force here. Look at this, some force they apply. All right, that force per unit area itself is known as a fluid pressure. That is the meaning of fluid pressure. All right, so the molecules of any fluid are in random motion. So these molecules are in random motion and they are going and hitting here as I am showing. So these are going and hitting the walls of the container. They are applying some force on walls of the container. That force per unit area is known as fluid pressure. All right, fine then. So you can make a notes of all those things. What is that? What is the first point? The first point is the molecules of liquid are in random motion. And second thing is they apply force on the walls of the container. That force per unit area is called fluid pressure. All right, I hope it's quite clear. The idea of fluid pressure you got to know. Now same is the case in gases also. In gases it is just that these are moving at a very faster rate because they are more free to move, no? So similarly they will also go and they will hit the walls of the container. Look here, they are going to hit the walls of the container on all the sides and they are going to apply some force here. All right, that force per unit area itself is known as what? That is known as fluid pressure. All right, so this is about liquids here, whatever I have shown here. So this was about liquids here, right? So in liquids, no, so there is no need that this container has to be closed. Even though it is open, it's okay. Okay, because we are talking about liquids here. Alright, so in liquids the top of the container can be open also, but in the gases, whenever we talk about gases here, so in the gases this should be closed, the top of the container should be closed, otherwise these gases will be escaping. Alright, if it is not closed they will escape, that's why the top of the container should be closed. Alright, I hope the concept of fluid pressure is quite clear. Alright, now let us concentrate on one topic, that is force on submerged objects in liquids. What is the meaning of submerged? Submerged means the objects which are there in the liquid, that is called as submerged. Okay, and there are two types of things. One is a partially submerged object. Partially means half inside the liquid, or some part of the object is inside the liquid and some part is outside the liquid, that is known as partially submerged. Completely submerged means the whole object itself is there in the liquid, that is completely submerged or fully submerged. Partially submerged means some part is inside, some part is outside. Let us try to understand what is this force on submerged objects in liquid. Alright, let us take some example here. Let us take an object here. Okay, here is the object. Okay, let us take here is an object. Okay, this is some iron piece or any body. Okay, one body is there, some part of it is look at this, some part is outside and some part is inside the liquid, so that's why it is known as partially submerged object. And let us assume these are the molecules of gas roaming around. Now what happens here, already you know that these molecules are in random motion, right? So these will go and hit this. Look at this, these are going and hitting this, these are going and hitting this, and here also these molecules are coming and hitting this and they are going back here also. Alright, so now if you observe, so both these forces, whatever I have shown here and here, they are balanced forces. There is more chance that from the left side 100 molecules are hitting, means on the right side also 100 molecules will be hitting. So these are the example for balanced forces, so both of them will cancel each other. Alright, the net effect will be 0, the net force will be 0, the net horizontal force will be 0. On horizontal level there will be no force, so both will be getting cancelled. Now look at this bottom, so here the molecules will be coming and hitting, look at this, they will be coming and hitting here. Okay, so this body will experience an upward force, look at this, this body is experiencing an upward force here. Now this entire body, if you write it in the form of a single point, actually this is known as free body diagram. What this is known as? This is known as a free body diagram. Free body diagram means showing all the forces on that body. Okay, this you will study in 11th class again. Free body diagram means on that body how many forces are acting. If I show that, then it is known as free body diagram. Now on this body how many forces are acting? The first force is acting downward here. Okay, so what is that force? So that is weight of the body. That weight is equal to mg, we know about that. Alright, and how about the second force? This body, this entire body, whatever I have shown black here, so this entire body is experiencing its weight downwards, and it is experiencing one upward force also. Look at this, it is experiencing one upward force. Alright, so let me show that upward force here, and we represent this with FB. What is that? FB. What is that? FB means the meaning of FB is a Buoyant force. What is that? Buoyant force. I will give the definition of that also. No need to worry. Buoyant force means whatever partially submerged object is there, no, that partially submerged object or completely submerged object for that matter. So inside a liquid, it will experience an upward force. As it is experiencing an upward force here, you can see here. So this is the upward force it is experiencing, right? So that upward force experienced by an object which is partially submerged or completely submerged in a liquid itself is known as a Buoyant force. Alright, so I want you to show about that completely submerged object also. That's why I'm not giving you the complete definition. Now you can see here, what you can observe here is, this body is there, no? So this is the entire body, whatever I have shown black body there. It experience one downward force, that is weight, and it experience an upward force inside the liquid, that is only known as a Buoyant force. Alright, fine then. Moving forward, let us talk about this force on completely submerged object in liquid. How about completely submerged object? For example, this is the the fluid or liquid what we have. In that, if we have an object here, okay, here is the object which is completely submerged, which is completely inside the liquid. All right, now what happens here? Please tell me. From the left side, the molecules will be coming and hitting. All right, that is there for sure. Okay, from the right side also the molecules will be coming and hitting. Look at this, but these forces are equal. These are the balance forces, so that's why they cancel each other. We know about that. Now here there is upper surface also and there is bottom surface also. On the upper surface, the molecules will be coming and hitting here. They are applying some force here. Look at this, they are coming and applying some force. All right, and at the bottom also there will be some force. The molecules will be applying some force here. Look at this, I am showing that also. All right, I am showing that also. And one thing you must have observed, already this left force and right force, they cancelled each other, that we know. Now from the top I have shown these arrows little smaller, that means less force. What is the meaning of this? The meaning of this is it is experiencing very less force from the top. Now how about from the bottom? From the bottom it is experiencing more force. All right, so that's why, for example, this less force is like if it is 10 Newton, we can consider this to be 20 Newton or 30 Newton. So the force from the bottom, whatever it is there, no, so this is more, always it will be more. Okay, it is experimentally seen also. And whatever is force from the top, so that is like less. So this less force can be nullified or it can be balanced from this bottom force. All right, so what will be the net force acting? This is 10 Newton will be cancelled by this 20 Newton. Another 10 Newton will be acting upwards. All right, to summarize this, I can write it in only one diagram. So one diagram can be written like this. For example, this is the body. Okay, so this is the body what we had. So we can leave the left force and we can leave the right force also, and we can leave the top force and we can write just from the bottom. So it is going to experience one upward force. So we'll mention this as the upward force, and this upward force itself is known as what? Buoyant force. All right, and we can write the free body diagram also. So once again I am repeating, what is free body diagram? We call it as FBD. Okay, FBD means free body diagram, and meaning of free body diagram is that on a particular body we have to show all the forces. For example, this is the body, this point is acting like a body. On this there will be one downward force. So what is that downward force? That downward force is weight, that is mg, and it is experiencing an upward force. Look at this upward force, I have shown you already. Upward force, look at this upward force. So it is acting, no, so that upward force is being shown here. Now which is more, which is less, that's a different discussion. Okay, we'll come to that in the Archimedes principle, but this is experiencing an upward force here. Two forces are there on this body. These forces are also there, I'm not denying that, but they are cancelling each other. And this force is also there, but it is getting nullified because of the down upward force is more, no. So because of this upward force, so whatever this upward force is there, because of that that downward force is getting nullified. All right, fine then. So let us take all those points whatever we have discussed. The first point is a partially submerged, look at this definition very carefully, a partially submerged or completely submerged object in a liquid experience an upward force. All right, fine then. So this phenomenon is called buoyancy. If somebody is asked you what is buoyancy, then you should be able to write a partially submerged or completely submerged object in a liquid experience an upward force. This phenomenon itself is known as buoyancy. All right, the upward force experienced by a partially or completely submerged body in a liquid is called buoyant force. That force itself is known as buoyant force. If the definition is being asked, what is buoyant force, you should be able to write this definition. What is that? The upward force experienced by a partially or completely submerged object or body in a liquid is called buoyant force. All right, and this is very important note. What I am giving you here is, the important note goes like this: due to this buoyant force only, due to this buoyant force only, bodies lose their weight inside a liquid and feels lighter. You must have experienced this, no? Inside a water, inside the water, the objects will be feeling much lighter. For example, here is a thread. Okay, here is a thread, and you are having this a stone, for example. Okay, a stone or a pot. Okay, to fill the water, you have one pot here. Okay, you have tied the pot. Okay, how to draw this pot? Okay, you have tied a pot, for example. Here is the pot. Okay, so here is the pot, and you have tied this to a rope. Okay, here is the rope. All right, so here is a rope, and you are holding it outside. Okay, outside it may feel a little bit heavier for you, because on this body what is acting? The only weight is acting. I am drawing this free body diagram of this pot right now. So W is equal to what? It will be there, mg, weight will be there. Now if you put the same pot inside the water, for example, this is the water. All right, so inside that water, you are having this pot right now. For example, you have this pot and you have tied to a rope and you are holding it. Means now what will happen? This pot, it is filled and it is inside the water. Now it feels lighter. Why? If you draw the free body diagram of that pot, look at this. This is the point. So here is the weight downward, not denying of that. So weight of this pot is acting downward, and it is experiencing an upward force or not? Look at this. It will be experiencing one upward force, buoyant force. All right, so it will be experiencing one buoyant force. Now this weight is there and this upward force is also there. For example, weight acting downward is 200 Newton and some 20 Newton is acting above. Means what will be the total downward force? The total downward force in that case will be 180 Newton. Can you observe that? 200 Newton and 20 Newton, their opposite, means 180 Newton will be acting downward. So this pot will be weighing only 180 Newton. Now how about here? There is no upward force, so it will be acting downward only, and you will feel a weight of 200 Newton. And definitely this pot, it starts to feel heavier outside the water. All right, so that's why what I'm trying to say is that due to this buoyant force only, bodies lose their weight inside a liquid and feels lighter. Okay, so if they ask you the question, why do bodies lose their weight inside a liquid and feels lighter, then you should be able to write the answer. It is due to buoyant force. Due to buoyant, they feel an upward force, and due to that they feel lighter and they lose their weight. I hope the concept is quite clear. All right, so fine then. I hope the concept of fluid, okay, the concept of fluid pressure, okay, observe them once again, make notes. And the concept of these submerged bodies, okay, how much force they experience. Whatever submerged bodies are there, the submerged bodies always experience an upward force, right? So that phenomenon itself is known as what? Buoyancy. And whatever upward force they are experiencing, that is only known as a buoyant force. And bodies lose their weight. Bodies will be losing their weight. They lose their weight in liquid. They lose their weight in liquid due to what? Due to buoyancy. Due to buoyancy only they are losing their weight. All right, so these are the highlights of this lecture. So make it sure that you are giving it a thumbs up, you are liking these videos. This will be very useful for you, and share these videos and subscribe to the channel. Thank you very much. Have a good day and bye bye.